Through the last century, the Rubik's Cube has been the most sold toy in all the world, and there exist lots of them with different shapes and a variety of colors, but all they share a thing in common: they require intelligence to be solved, and only humans have this intelligence. So I asked myself, would it be possible to construct a robot with such intelligence? So let's see how it works. The main structure of the robot is the base. This structure has the function to rotate the cube over the vertical axis, the y-axis. And it has a gear system that allows the movement translation. The small gear on the left is the driving gear, which is connected to the motor, and the central gear is connected to the base. So the right gear only has the function to remove any type of vibration. The second structure is the pin. The pin, it also has a motor and has two functions. The first one is to rotate the cube over the z-axis. As we have already seen, the base rotates the cube over the y-axis. So, as we can rotate the cube over two axes, we can orientate the cube in any way. So, we can put any face wherever we want. The second function of the pin is to hold the cube while the base is rotating, so only one face of the cube is rotated. As we have already said, we can orientate the cube in any way, so we can put any face in the base, and once it is in the base, we can rotate it, both clockwise or counterclockwise. So we can say that the robot in a mechanical way can solve the cube, but in order to solve the cube, the robot first has to read it. It has to detect its colors, and that's why there is a color sensor structure to move forward and backward the color sensor, so that it can detect the different colors of the pieces. This structure also has a motor and a gear system, which transmits the movement. The color sensor can be in three different positions. The first one is above any vertex to detect the color of any of the four vertices on the top face. The second position is above any edge in order to detect the edge's colors. And finally, the central color. The color sensor has two elements, an RGB LED and a light sensor. The RGB LED, what it does is to emit red, green and blue lights in small intervals of time, so we only see a white light. So if we illuminate a red material with red light, because of physics, all this light is reflected to the light sensor. Instead, if we illuminate with green light a red material, part of this light will be absorbed by the material. So the green light will not reach the light sensor. So, depending on the percentage of red, green and blue light that arrives to the light sensor, we can know what color is detecting the color sensor. Here we can see these values for the red material, for a blue material, for an orange material, for a green material, for a yellow material and for a white material. Once the robot has already detected the colors, it sorts them by two different ways. The first way is to sort it by faces. The cube has 6 faces, and each face has 9 colors. What it does is to sort these 9 colors linearly, so one row is generated by each face. And as there are 6 faces, the result is a 6 by 9 table. The second way is to sort them by pieces. The Rubik's Cube has 26 pieces. 6 of them are the centers. It also has 12 edges, which join 2 faces, and 8 vertices, which join 3 faces. As we can see, 2 colors are attached for each edge, and 3 colors are attached for each vertex. In this example, it is shown that the edge number 1 is the orange-blue edge, and the edge number 2 is the red-white edge. For the vertex, the same thing happens. For example, the vertex number 1 is the yellow-orange-blue vertex. It's important to remark that what it does this robot special is that applies artificial intelligence to solve the cube. So what it does is to convert intelligent data as colors or pattern in digital data, for example numbers, which which is the data that the robot understands. Whatever, the robot starts to solve the first step, the cross. The cross is formed by the 4 edges on the top face of the cube, and it solves these edges one by one. For example, to solve the red-white edge, which is the edge that joins the white face and the red face, what it does is to search for its position and orientation. As we have sorted the colors by pieces, we know where is this piece situated. So, as there are 12 different positions and 2 orientations for each one, there are 24 different combinations. And each one has its due combination of movements that are needed to put the piece on its place. In our example, we see that the red-white edge is in the second position. And the orientation is not white-red, it's red-white. The robot has to do the R-F movement, where the R means right face counterclockwise and the F means front face counterclockwise. And the robot has solved the first piece of the cross. To complete the cross, what it does is to do the same with the other 3 pieces. The second step to solve the cube is to solve the 2 top layers of the cube. This step is similar to the cross step, so depending on the orientation and position of the edges, it does a combination of movements or another. The third step is the resolution of the down face, usually the yellow one. In this case, what humans do is to search the shape generated by the yellow pieces. There are lots of possible shapes. For example, here we see the T shape, the thunder shape, the cross shape, etc. So depending on the shape, the robot does some movements or others. What I have done is to convert the shape in a digital pattern. As we explained before, we have sorted the colors by face, and each face has 9 colors sorted linearly. So I attach a 1 for yellow colors and a 0 for non-yellow colors. Here we can see the T case, that would be the case 1 0 0, 1 1 1, 1 0 0, or the cross case, that would be 0 1 0, 1 1 1, 0 1 0. So, depending on its pattern, it will do some movements or others. The last step is to finish solving the cube. The last colors that remain to solve are the ones surrounding the yellow face. So, what I do is to analyze how are sorted the colors remaining. There are 12 colors, 3 red ones, 3 blues, 3 oranges, and 3 greens. In this case, for example, the order would be red, green, orange, blue, blue, green, orange, red, red, green, orange, blue. And depending on this order, the robot does some movements or others to finish solving the cube. And once the robot has done these movements, luckily it has solved the cube.